Okay, thank you, Terry, and good afternoon, everyone. My name's Steve Naylor, and I'm a data scientist working out of the Health and Safety Executive's Science Division. And I'm here today to provide a perspective on how we feel that analysis of multimodal stream data can help HSE as a regulator of health and safety to make better regulatory decisions in relation to its responsibilities. HSE, as I'm sure you know, is the regulator of health and safety at work, and one of the functions of the Science Division, and particularly the data analytics team that I work out of, is to make use and tap the value of the operational data that HSE generates from its inspection activities, its investigation activities, and the incident information that gets reported to HSE by industry. And what I'd like to do with the presentation today is just to give you a bit of a taste and an overview of some of the ways in which we use data analytics to support our decision making within HSE, an idea of the sorts of data sets that we work with, the sorts of methods that we use and are looking to use perhaps more in the near future, and an idea of some of the associated challenges with those traditional approaches to analysing data. I'd then like to introduce the concept of Industry 4.0, which is a term given to the emergence of a new technological and data landscape that's emerging in industrial workplaces today, and what some of the potential opportunities and challenges are of using some of the analytic techniques that you're discussing today in relation to that particular landscape. I'd then like to present a case study that just illustrates application in the flesh, if you like, a piece of work and a potential project that we've been looking to establish with the Alan Turing Institute and the University of Manchester, that's looking to actually make use and demonstrate the value of some of these techniques in health and safety contexts. Okay, so I'd like to start just with providing, I suppose, a definition of data analytics from our organisation's perspective, and it's really not dissimilar to, I suppose, other organisations' view of what data analytics does and what we're trying to achieve. So we view it as really a collection of quantitative and qualitative techniques and processes for generating information and knowledge from the raw data sources that we have at our disposal to inform organisational decisions. So from our point of view, we're to inspect the reasons why certain failures in health and safety occur. And I think we can generally classify the broad techniques that we use day to day into one of five broad areas, five categories of analytics. On the one hand, and perhaps most simplistic, there's our descriptive analytic techniques, which are essentially all focused around operational reporting and looking to quantify and summarise what happened, where, when and whom in relation to health and safety problems. If we then move slightly up the knowledge pyramid, and as we move up, the value of the knowledge and the insight that we generate gradually accumulates and increases. We have our diagnostic techniques, which are essentially looking to consider how and why certain failures of health and safety occur in workplaces. They're essentially looking at the root causes of why certain things are happening, with a view to identifying optimal ways of actually preventing them in the future. We've then got a category of analytics essentially centred around data mining, which are essentially looking to interrogate large, disparate, complex and diverse data sets to identify new and emerging risks that we didn't know existed before, new associations between problems and potential consequences. Then if we move up further still, we have our predictive and our optimization techniques, which are more focused on attempting to predict and forecast what might happen in the future given a particular scenario, and also to consider what potentially the optimal courses of action to take, again, given a particular scenario. And then we have at the very top of the pyramid, if you like, our prescriptive techniques, which are essentially looking to answer those policy, strategic and operational questions of, okay, given what we know now, what next? What do we need to do next? Okay, so just to give you an idea of the data landscape that we as data scientists work with within HSE, and the sorts of data that we have available to generate useful insights and knowledge. If we go through each of them in turn, I mean, generally the whole process of data coming into HSE obviously starts with perhaps some accident or some concern that gets reported by industry, member of the public, or what have you, and that's illustrated on that left-hand side there, whether it be from employers or members of the public. And that typically triggers a red flagged incident that results in potentially a HSE inspector going out to a workplace and collecting more detailed information on the particular incident that's been red flagged. And that might then trigger a more detailed specialist investigation where specialist investigators go out to the workplace and collect more detailed information on specifics. It might then lead to a prosecution or an improvement or prohibition notice being issued, and some other consequences in that sense. And at each stage along the process, we're generating more and more information of different types and in different formats. And we effectively have all this information at our disposal. The primary aim of the information systems that we have in HSE are really to support those operational processes of HSE inspectors going out and doing their jobs and responsibilities. But what we're increasingly realising as an organisation is that this operational data, if we can get it into a format enabling us to use it collectively, we can really make some high value insights from the data that we have to actually support some longer term objectives of the organisation. Okay, so I don't want to get too bogged down into some of the detail and the specifics of health and safety and some of the key issues that are important to us as health and safety professionals. But I think it's useful just to consider and break down health and safety performance into its key areas, its key dimensions, if you like. And at the heart of everything that we do are health and safety risks. So the potential for harm and failures to occur in workplaces. And they manifest in many different forms. Effectively, they're a function of a number of key factors. Essentially, and probably most importantly, the inherent hazards that are evident in a workplace. Also, the work activities that workers are actually doing that bring them into contact with those hazards. The characteristics of the workforce actually delivering those work activities, and more generally the characteristics of the organisation and the management systems in place that are designed to actually control risks and mitigate failures actually happening. And most fundamentally are the risk controls that are in place to mitigate and prevent failures in health and safety actually happening. And with this scenario, this landscape, if you like, we can consider, I suppose, one of two scenarios that might take place. One effectively is business as usual, in that the risk controls are actually maintained and that there's effectively business as usual. No harm to workers, zero harm. On the other side of the coin, if you like, there's the potential for varying degrees of failure to take place, and that might lead to potential consequences and health and safety outcomes, whether they be human safety related, process safety related, or human health related. And in each one of these boxes, if you like, I think there's the potential to generate and accrue information and quantitative structured data also that allow us to characterise the essence of what's going on in each of these areas. And that's really what the data analytics team at HSE is all about. Effectively making use of the routine operational data that's generated by HSE. I think we can think of that whole process of health and safety performance in a more simplistic way, if you like, and actually consider really 4 categories of performance indicator. On the one hand, there are when things go wrong and when things go right. And we conveniently distinguish between these with the terms safety 1 and safety 2 type indicators, and they're effectively one and the other side of the same coin. One other way of thinking about performance indicators is to consider them in relation to the consequences and the outcomes that we're actually trying to prevent. So we have lagging indicators that are very much focused on the outputs and the outcomes of the control measures and the procedures in place to prevent adverse outcomes. They're effectively our lagging indicators. But we can also consider that there's real value in collecting information on some of those upstream indicators of performance, effectively those leading indicators that determine potentially whether or not a particular consequence, failure or outcome actually takes place. And I think we can actually place those outcomes on a frequency continuum with, on our left-hand side of the continuum, are unwanted consequences. So effectively, when the health and safety system breaks down and those adverse consequences actually happen. In the middle of the continuum is what happens most of the time. It's our business as usual. It's kind of, well, you know, that this is our desired outcome, this is what we were expecting, this is essentially what we need to happen to meet our regulatory requirements and to keep our workers safe. And then in those minority of situations on the right hand side, we can have those positive surprises where, you know, the outcomes are even better, if you like, than what we perhaps envisaged and imagined. But I think it's generally recognised that traditional health and safety focuses on those, historically it's focused on those unwanted outcomes in terms of both the data that we generate and how we use it, and in terms of how we think about what the key objectives of what we do. So effectively to prevent the adverse and the negative consequences actually happening in the first place. I think it's worthwhile pointing this out, and I'll revisit this whole perspective of thinking about safety in a later part of the presentation. I think the other thing that would be useful to do is for me to provide a perspective on what I feel are some of the key technical challenges as a data scientist working in health and safety and working with the data sets that we actually have within the organisation. I think the first thing that's very apparent is, and it's again probably not too indifferent to other organisations, is the large volumes of data that we have at our disposal and we're kind of expected to actually tap and make use of, and the fact that they're in multiple formats and held disparately across the organisation in different networks, different locations, whether that be free text or coded structured data. That's a real challenge for us as data scientists. I think the other thing is that we recognise as health and safety professionals that there is an over-reliance on those lagging indicators of performance and measuring performance based on the frequency with which those negative things actually happen. And there's a recognition that you know, we kind of need to change that perspective, and we recognise the value of that. But the key challenge is accessing and identifying data sets and data sources that allow us to actually do that. I think there's also a recognition that we really do need to make use of some of those high-end, more complex analytic approaches and techniques that are used in other areas of science and engineering. I think we focus a lot on the descriptive and the diagnostic and the knowledge discovery type approaches, and we really do see that, that there's a need to be more proactive in how we manage risks and consider about outcomes and try and predict things happening so we can actually prevent them in the future. I think the other key challenge is that probably the main things that we want to predict, that those real high magnitude, high consequence events are like in many disciplines, rare, and we don't really have an awful lot of data on them. So it's a real challenge for us to actually build up a picture of the circumstances in which these events are actually happening, so we can learn a bit more about them. And again, I can pick up on that point later on. I'd like to come back to this concept of Industry 4.0, essentially a term that's used to describe the change in digital and data landscape that's actually occurring in modern workplaces today. And I think we can actually trace back the broad changes in the workplaces back to the 18th century, where manual labour was first starting to be replaced by steam power and machinery that was actually powered and driven by steam power. That was really, I suppose, the first big paradigm shift in how workplaces actually operated day to day. We then had in the 19th century the replacement of steam power with electricity, the electrification of workplaces, and the start of mass production, and that was another key shift and change in the way workplaces are actually operated. I think the third big change was the emergence of the use of computer technology, electronics, and the arrival effectively of the automation of particular work processes, the use of robotics and like. That's generally regarded to be the third revolution, if you like. And that brings us on to the fourth revolution, Industry 4.0, which describes the emergence of the use and introduction of cyber physical systems in workplaces, the emergence of smart devices, the desire and push to make use of machine learning and artificial intelligence, and the decentralization of the way data is actually used and analysed in workplaces from a decision-making perspective. That is really the focus of my talk today. I'd like to, with the last little bit of time that we've got, just consider what this means in terms of the use of data science in these contexts. I think in terms of what it means at the factory floor level and some of the specific technologies that are actually being used, we can kind of assign that label of Industry 4.0. We've got a number that are actually illustrated here. So we're talking about the use of wearable devices in workplaces to actually provide that fine resolution information relating to what workers are doing and how they're doing it, and what some of the effects are. We have them in everyday life to monitor our lifestyles, and there's a recognition and a growing use of them in workplace situations. We have the use of virtual reality, the gamification of training, which again is I think a result of this shift in workplaces. We have the use of telematics, the use of GPS and HAZCOM beacons that are generating huge amounts of stream data. We have also the use of drones, unmanned vehicles, CCTV, video data streams effectively that we're increasingly we can make use of. We have the use of predictive analytics to basically use the information that sensors attached to machinery are generating to effectively predict when these machines are likely to fail, rather than the traditional schedule-based consideration of maintenance regimes and the like. And we have the move towards enterprise systems for health and safety, and opening up the data that we potentially have access to, so everyone can actually make use of it. And I think the common thread running through all these technologies is the huge amount of data that is generated as a result 24/7 that we potentially can make use of. And I think it opens up opportunities for doing health and safety in different ways, but also some challenges. I think in terms of opportunities, what really interests and excites us is the potential to effectively move our analytic approaches that we're using in health and safety up this knowledge pyramid. So rather than actually considering retrospectively what happened in the past, and effectively data analytics being a batch analysis exercise and task, to actually thinking about doing things more real time, to generate insights that can be acted on more real time as well. So let's think about the new challenges that we're actually facing now in this new workplace and industrial landscape that we're faced with. I think that the one thing that's even more apparent now is that the data landscape is even more diverse than it was before. It's not just about text data and information and written reports and your simple quantified data sets. There's the data generated by all these different sensors that are actually generating information in workplaces relating to vibrations and the noise and exposure to pollutants. There's also the fact that the data sets that we're working with now are effectively generating data 24/7, and we need to think about how we actually shift the way we actually work with our data away from those batch analysis type tasks to effectively considering data real time. And then there's the general trend towards the use of machine learning based statistics and artificial intelligence, and trying to actually automate the decision making processes in relation to, from our perspective, the control of health and safety risks. So as I said earlier, effectively pushing up where we're operating as data scientists in that prescriptive operational analytic domain. And I think what we basically can see is that we can increasingly move away from the focus of the work that we do being at this bottom right hand side of the schematic here, always just acting reactively, waiting for things to actually go wrong, and move up the focus of our analysis to the day-to-day, to the things that workers are actually doing day-to-day in the workplace, the way they're actually carrying out the work activities and what the potential implications are for their safety, and effectively moving away from retrospective analysis of failures to trying to detect early warning signs of major things that might be around the corner. I think that's really what we feel potentially this approach to analytics can potentially bring us. I'd just like to finish now with a very quick look at a case study. So as I mentioned earlier, one of the data formats that we're increasingly trying to make use of, both ourselves as regulators but also industry as well, is video data generated by CCTV, drones and alike, because it gives us that real at the coalface view of actually what's happening in workplaces. And it's a topic area that is the focus of a project that we're looking to deliver with the Alan Turing Institute, essentially bringing two research programs together. HSE's Discovering Safety program that is centred around intelligent use of data for health and safety decision making, and the Alan Turing Institute's Data-Centric Engineering program that's looking to actually apply high-end analytics to address engineering problems. And we feel that there's real value in bringing these two programs together with reference to some projects that we're thinking about now. One is a study that's effectively looking to use video analytics to auto-detect unsafe behaviours in workplaces using video data. And we just have a very simple illustration of I suppose the research that is involved with this. So effectively using established existing archives of video data of what's happening in workplaces, and health and safety specialists annotating that data set to actually identify the behaviours that are regarded as high risk and potentially problems around the corner, and then using existing techniques to look to actually train algorithms to auto-detect these labelled cases themselves, and potentially looking then and thinking about how we might deploy that in health and safety contexts. And we tried to illustrate a few examples just with the last two slides here. So we can imagine that if we have CCTV deployed that's monitoring workers that are potentially exposed to harmful chemicals, but we can monitor and see the way in which they're actually carrying out those activities and whether there are any situations and scenarios where their exposures are potentially higher than what's safe. We're also able to monitor ergonomic issues potentially. So focusing specifically on workers that are carrying out manual tasks and whether the way in which they're actually carrying out those tasks day to day is potentially increasing their risks of problems. Also, workers actually using ladders and working at height, and again, whether there's risks there. And I think the key thing, what we're trying to bring to the table, if you like, is just focusing in on those behaviours and work activities that might actually heighten risks. I think time has beaten me, so I'd just like to sum up the main themes of what we've been talking about. I think the fact that traditional safety focuses on things going wrong, the fact that that's a small portion of the total operating experience, and whether a failure in health and safety results in a cut finger or an amputated arm is very often a matter of chance. So that there's value in looking at things in different ways, using new technologies and the data that technology generates to think about health and safety in a different way, and effectively trying to move away from reactive health and safety more towards detecting those early warning signs of problems around the corner. And I'll leave it there.
Thank you very, very much.
Thank you very much. Very interesting. Especially the last part of your talk is related to early warning signals that I'm working on in time series. And I know we usually look at spectral properties, and you are putting this into context of video streams, which is multidimensional early warning signal. So mathematically, what exactly is it already work in progress, or it is a plan for future, because it's an extremely challenging task?
Yeah, I mean, it's very much in the early stages of discussions. I mean, but we have obviously access to the data, and we're in early discussions with Alan Turing Institute, and actually Terry Lyons is party to those discussions, and we're just trying to scope out what we could potentially do in that area.
Thank you.
Are there any more questions? I think we should probably postpone them.
Yeah, apologies for going a bit over.
That's no problem. Let's thank Steve then.